So in order to build this error function, let's recall something we saw before, the perceptron algorithm. The perceptron algorithm works in the following way. You have some data points like this, blue and red, and we want to find a perfect line that splits them. Now, a perfect line has equation wx plus b equals 0, where w and x are vectors and b is a scalar. So it looks more like this, w1x1 plus w2x2 plus b equals 0. As a quick example, let's say the equation is 3x1 plus 4x2 plus 5 equals 0. So we want to punish this line with some error function, and the error function roughly measures how many points are misclassified. It actually measures something closer to the sum of the distances of these misclassified points to the boundary. So we can split this into two sets, the red points and the blue points. And our error function is going to punish those two red points in the left that are on top of the line, and those two blue points in the right that are below the line, but it's going to punish them according to their distance to the main line. So half of our error function will look like this. It's going to be the blue area that is over the line. So the more a red point is into the blue area, the more it gets punished. This means that the point that is close to the line gets punished a little bit, and the point that is far from the line gets punished more. And the other part of the error does the complete opposite. It punishes the blue points that are in the red area. The points that are close to the line don't get punished much, and the ones that are far from the line get punished a lot more. But let's actually put some math here. Let's ask how much is the error at every point. So we have that our equation, as we said, is wx plus b equals 0, which is a linear equation. Now wx plus b takes all the values, so in particular, it is 1 at the line that is parallel to the main line and a little bit above, and then it takes the value 2, 3, 4 successively. And the same thing at the negative side. It takes the values minus 1, minus 2, minus 3, minus 4, etc. And basically, this is going to be the error. It's going to be the value of wx plus b. Actually, since we have negative numbers, it's going to be the absolute value of wx plus b. So now let's calculate the errors for the misclassified points. This point, for example, gets an error of 2.5, since the red point lies in the 2.5 line where wx plus b is 2.5. This one has an error of 0.5. And these points over here have errors of 1 and 2, since, let's remember, the error is the absolute value of wx plus b. And then to calculate the whole error that this model gives us, we just add them. So this model gives us an error of 6. So now we put these two together, and we conclude that this model has an error of 6. And the idea will be to minimize this error using gradient descent in order to find the ideal w and b that give us the best possible cut. And that is the perceptron algorithm.